This is our video for solutions for the bar chart and pie chart lesson. As we go through these problems, I'm going to place a little paper that shows you what number we're doing. So if you want to skip ahead to the numbers that you need the help with the most, or you want to come back to this and quickly find a problem, you can use the thumbnail at the bottom of the video to move forward or move backward if you need to. I'm going to see if I can actually show you what I'm referring to. So if I go to, let's say, calculating and rounding percents, because this is YouTube, if I if I click on the video and I go down to the bottom and drag across the time track bar, it's gonna show you a thumbnail of where you're at in the video. So that's why I'm going to put up the problem for like 2 or 3 seconds. So as you go through the bottom of that bar, the thumbnail will show you what number we're on. So like I said, if you want to move forward or move back, hopefully that'll make it a little bit easier for you. So we are starting with number 3 in the bar chart and pie chart practice problems. So the setup is, it is estimated that 77% of Americans use a smartphone. The table shows the percent of people in various age groups who own an iPhone. So we're looking at only people who own an iPhone. Can you display the data as a bar graph, a pie chart, or both? So the first thing that I know for sure is that we can display it as a bar chart. Anything that is a categorical, any data that is categorical, can be displayed using a bar chart. And I know, one, because we're in this lesson and all we're looking at is categorical data, that it has to be that type of data. And 2, I know that these different age groups, you wouldn't average these age groups because they're a range of ages. So it would not make sense for us to go in and average these different values that we're getting for each category. So a bar chart is definitely a yes, because categorical data can always be displayed with a bar chart. So the one we really have to think about is the pie chart. Now, the feedback or the guidance that we have is that the categories must be made, or the categories must make up a whole, and the percents must add to 100. So the first thing that I'm going to check is what these percents add to. So I'm going to go through and add the age groups. They end up adding to 125.1%. So this data can only be displayed with a bar graph. The reason we can't use a pie chart is that these categories do not make up a whole. So what I am used to seeing as a response to this question is bar chart only, because the percents don't add to 100. Do not write that. So I'm going to say that one more time and actually make myself bigger so that I can eyeball you why I say this. When you give a reason why you can't graph or use a pie chart to display the data, you never want your reason to be the percents don't add to 100. The fact that they don't add to 100 is your indication or your hint that the categories do not make up a whole. So that is what we are going to write instead. So we are going to write that the data can only be displayed with a bar graph. So I guess I should write that. The data can only be displayed with a bar graph because the age groups or the categories do not make up a whole. So what do we mean they don't make up a whole? I know that they don't. My first indication was that they don't because they equal 125%. So what does that really mean though? What that means is that these categories that you have here, each category is its own whole, meaning that when we say we have the age group 18 to 24-year-olds, this percent is the percent of 18 to 24-year-olds that have an iPhone. This group is the percent of 25 to 44-year-olds who own an iPhone. This is the percent of 45 to 64-year-olds that own an iPhone. This table is not telling you of all the people that own an iPhone, 36% of them are 18 to 24. That's not what this table is telling you. So I'm going to say that again. This table is not telling you that of all the people that own an iPhone, 36% of them are 18 to 24. Because, well, I know because I'm going to show you a visual of how I know that, but one indication is, what about people that are younger than 18? If this were based off of all the people that use an iPhone, we would be missing an important piece of data because we don't have people under the age of 18. So the percent's not adding to 125, and that missing category, that missing age group, are what tells me that these categories don't make up a whole, and that this table is not telling me of all the people that use a cell phone or use an iPhone, 42% are 65 and older. So what is this table telling me? This table is telling me that of the people that are 18 to 24 years old, so I'm going to draw a little pie chart here, and I'm going to label this pie chart 18 to 24 years. This table is telling me of the people that are 18 to 24 years old, 36% of them use an iPhone. So this is the first piece of information that the table is giving me. This is telling me of people aged 18 to 24, about 36% of them use an iPhone and 64% of them do not. The next one is telling me of all the people that are 25 to 44 years old, 23.7% of them use an iPhone, and the other 67% don't. 77% don't. So each one of these categories is its own whole. These categories do not make up a whole because each category that you see is its own whole. So I'm going to say that one more time to hopefully clarify what I'm saying. This table does not show you a whole, that's not a great way to say it. This table does not make up a whole. The categories in this table do not make up a whole. So this table is not telling you of all the people that own an iPhone, 36% are 18 to 24, 24% are 25 to 44. And the reason that I know that, or the hint or indication that that is not the case, is that one, my percents don't add up to 100, and two, I'm missing the category of people younger than 18. So those two things told me I shouldn't use a pie chart because these categories do not make up a whole. So then to further figure it out, I looked at this and said, okay, well, what is it telling me? Well, this is telling me of people age 18 to 24, 36% of them use an iPhone. And of people 25 to 44, 24% of them use an iPhone. So each one of these categories, this is category 1, is its own whole. So that's what I mean by a whole, this little pie graph that I have down here. This age group 25 to 44 is its own whole. So this table is giving you different age groups and the percentages or the percent of people in that age group who use or don't use an iPhone. So I drew this a little bit differently on my key, and I just want to show you that. I did not use the same wording over here. I decided to write something different, but essentially this is the issue. These categories do not make up a whole. Each category is its own whole. So if we wanted to use a pie chart for this table, we would have to make 4 separate pie charts. We could not make one pie chart with the percents that they gave us. The hint or the indication of that is because they don't add to 100, and we're missing the age group that's 17 and younger. So once again, our solution to that is the data can only be displayed with a bar graph because the age groups do not make up a whole. Okay, next up, which age groups have the highest ownership? So that's going to be the youngest and the oldest. Which age groups have the highest ownership? That is youngest and oldest. And then they want you to explain why that is. So if you haven't written why you think that the highest percentages are the youngest and oldest, I want you to pause the video and come up with a reason. There's no right or wrong answer. As long as what you're saying makes sense, as long as it's a reasonable reason or a reasonable justification for why older people would use an iPhone or younger people would use an iPhone, then you're fine. If you end up writing something different than me, but you prefer your answer, keep your answer. Don't use my answer. So this is one that you can do without me. You are just trying to come up with a reason why you think that the highest percents are the youngest and oldest category. So pause now and do it if you haven't already. Okay, my justification is I think young people could see Apple phones as a status symbol, like it's trendy or it's what the cool kids have. So it would make sense to me that the younger category has a large percentage of people that use an iPhone. And then the oldest category, I personally think it's because iPhones are really user friendly. So if we want to give older people who don't have as much experience with technology as we do, if we want to give them a phone, we should give them one that's easy to use. So I'm thinking that the youngest group is because it's like a status symbol, and the oldest group, it's because they're easy to use. If you didn't write those, like I said, that's fine. Use your reasoning if it makes sense to you and makes sense overall. Okay, the next problem that we are doing is number 4. So I'm just going to leave this up for a second. So if you're searching through the thumbnail, you can get there quickly. Okay, I tricked you because I needed to say one other thing about number 3. I do think that it is a really good idea for you to draw the separate pie graphs or pie charts. So I do think it's a good idea for your response here that you understand that this is why. Now remember, the response that I used was not this one. I wrote up a different one. So you would want to use this written response and maybe add in this visual to remind you. Okay, now really number 4. In a certain school district, students from grade 6 through grade 12 can participate in a school-sponsored community service activity. The following bar chart shows the relative frequencies of students from each grade who participate in the community service activity. So I want to go through this relative frequency table and just verify that I understand what all of these percents mean. So what this first one means is that 30% of 6th graders participated and 70% did not. 30% of 7th graders participated and 70% did not. About, I'm going to say 35, you could maybe go 36%. 36% of 8th graders participated in the community service activity and 64% did not. 9th grade, I'm going to say that's about 55%. 10th grade, I'm thinking is like 44%. 11th grade, 50%. And holy moly, seniors, what you doing? The seniors, only 10% of them participated in the community service activity and 90% of them did not. Now, if you add up these percents, we're over 200%, which means that we are in the same situation that we were here. These categories do not make up a single whole. Each grade level is its own whole. So 6th grade, what I mean by that is the whole is all of the 6th grade students, and the data is 30% of them participated and 70% did not. So you would never use a pie chart for this data. So I have that written in my key. I have percents do not add to 100. So that's my first hint that something's might be amiss, or there might be a reason why I wouldn't use a pie chart. And then I note each grade is its own whole, just like up here, each age group was its own whole. Okay, now I'm just going to go through and check these one at a time and see which one is the one that is supported by the bar chart. So the first one says, the greatest number of participating students was in 9th grade. This is not true. So I think at first read through, most people would think that that is true because 9th grade had the highest percent of students that participated. But that's just it. This is the percent of students that participated, not the number of students that participated. So let me show you why this isn't necessarily true. Let's say that you had, sorry, I have a different sheet that I want to show you guys. Let's say that in grade 9, you had 100 students, and in grade 6, you had 200 students. Okay, well, in grade 9, we had 55% of people participate. So we would take 100 times 55%, and that would tell you that 55 students in grade 9 participated in the service activity. In grade 6, only 30% participated in the service activity. So I'm going to take the 200 6th graders, multiply that by the 30% that participated, and this tells me that 60 6th graders participated. Well, even though this bar is the highest bar on our frequency table, because it's telling me the percent, that doesn't mean that that grade level had the most students. And this is an example of that. Grade 9 could have only 100 students, which means only 55 of them did the service activity. And grade 6 could have had 200 students and have more students that participate even though their percentage is lower. So it is not A. Okay, next up is B. The number of participating students in grade 6 was equal to the number in grade 7. No. And it's the same as the reasoning that I just showed you. This is telling you the percent of the grade level that participated, not the number of students that participated. So even though 30% is the same, they each had 30% of their grade level participate, one of these grade levels could have more students than the other, and then that would mean that grade level had more participating students. C, the relative frequency of all participating students in grade 6 and grade 7 combined is 0.60. So they're saying if you combine grade 6 and grade 7, 60% of the students participated. No, relative frequency doesn't work that way in this case because we don't know that these grade levels had the same number of people. That's the first issue. The second issue is that you cannot combine the two categories, and here's why. So I'm actually going to write this in as an example, and I'm going to use easy numbers. So let's say that grade 6 has 100 kids in it and 30 of them participated. That would equal a 30% participation rate. And then let's say grade 7 is exactly the same. They have 100 students, 30 out of 100 students participated. That is also a 30% participation rate. So right now, these two numbers match the percents up here in the table. Okay, well now they're saying combine them. So they're saying combine grade 6 and grade 7. Well, that means 60 students out of 200 students participated. When you plug that into your calculator and convert it, that's still 30%. So 30% of 6th graders participated, 30% of 7th graders participated. If you combine the two, it ends up staying at 30%. So you would say 30% of 6th and 7th graders participated. So it is not C. D, grade 12 had the least relative frequency of participating students. Yes. Notice that they are not, the problem is not saying grade 12 had the least number of participating students. They are specifically talking about the percent. And 12th grade did have the lowest percent of participation. Grade 11 had the greatest relative frequency. Grade 11 was 50, grade 9 was 55. So that's why E is not true. So the reasoning for A, B, and C is really kind of complicated, and hopefully you feel okay about the explanation. If you do, okay, so I was saying if you do not understand my reasonings for the solutions for number 4, please email me, come see me, send me a video message, and I will do my best to explain in a different way so that you have a better understanding. Okay, next up, we are doing number 15. I'm just going to leave this up for a second. Okay, number 15 is similar to the iPhone problem. Young people are more likely than older folk to buy music online. Here are the percents of people in several age groups who bought music online in a recent year. Explain why it is not correct to use a pie chart to display these data, and then make a bar graph. So I am hoping at this point you can fully answer this question without me. I am going to go through the solution, but I want to make it clear that at this point, if you're struggling to answer this, you may want to get a little bit of extra help before we take the quiz on this. So my response to part A is the categories do not make up a whole. Each category is its own whole. And then I gave an example. 12 to 17-year-olds is its own category. 24% bought music online. 76% did not buy music online. So if you wanted to use a pie chart for this data, you would have to make 7 different pie charts. Okay, the next up is the actual bar chart that they asked us to make. Yours doesn't have to look exactly like mine, but the highlighted portions do. So remember, you always need to scale and label your axes. So if this were a quiz, or if I were grading this and you did not label the bottom age group and you did not label the side percent that bought music online, you would miss points for this problem. Notice that I am using the exact wording from the table. So percent of people that bought music online, age group, those are the labels that I used. When you go to scale your y-axis, you want to look at the biggest number in the table. The biggest number was 24. So I scaled by 5s and was able to get as high as 30. Then I labeled each one of my bars, did my best to be as accurate as possible, and your bar chart should look similar to mine. You could label in the bar, you could label below the bar, but you have to make sure that you have the y-axis labeled as percent that bought music online and the x-axis that had age group. So the last question is, I need to hold up my sign. So last question is 31. Okay, so for which of the following would it be inappropriate to display the data with a single pie chart? Now, this problem is an excellent problem to determine whether or not you can identify what the whole would be for each set of data. So A, the distribution of car colors for vehicles purchased in the last month. Yes, you could use a pie chart. Your whole is all of the cars sold in the last month. B, the distribution of unemployment percentages for each of the 50 states. Well, what would that look like? If you were going to make a pie chart of that, the pie would have to have at least 50 different slices, because there are, I don't know how many states there are nowadays. There might be 49, there might be 51. I'm not even really sure. But you couldn't make a pie chart with that many different slices in it. That's the first thing that makes me think, well, maybe it's B, because I don't even know what that pie chart would look like. This pie chart would look like cars sold in the last month, and the different slices would be like red, blue, yellow, white, and then you would label the circle cars sold. This one with the percentages for each of the 50 states, I'm thinking I don't even know what that would look like. The next one, C, the distribution of favorite sport for a sample of 30 middle school students. D, the distribution of shoe type worn by shoppers at a local mall. Or E, the distribution of presidential candidate preference for voters in a state. So it turns out that the answer is B. I'm going to explain why. So the reason why is because it is similar to this problem up here. Each state represents its own whole. So you would need 50 pie charts. This one says inappropriate to display the data with a single pie chart. This one you would need 50 pie charts. And that is similar to this problem here where we had 4 age groups and you had to make 4 pie charts. Okay, so now you know that you can use a pie chart for A, C, D, and E. I would challenge you to do a rough draw of the pie chart like I did here, just to verify that you know how. So I would pause the video. I would really see if you could do a rough sketch of C, D, E, and then come back and see what I have written. Okay, so hopefully you really paused. I'm going to zoom out and I'm going to show you mine. So for letter C, your whole would be the 30 middle school students. The different sports could be football, basketball, soccer. You could add in volleyball if you wanted to. I'm sure that you could add in baseball. So actually BB could be either one. The distribution of shoe types. So the whole is the shoppers at the mall. The different kinds of shoes can be a heel, a boot, a sandal, Vans, tennis shoes. And then lastly, E, the distribution of presidential candidate preference for voters in a state. Not all 50 states, a state. So I have Utah as my whole, and then Trump and Clinton. Notice that in all of these pie charts, the slices are labeled with words because we're talking about categorical data. I hope that this is something that you really tried so that you have the best understanding of pie charts and categorical data as possible. So you will have a quiz on this at a later date. We may do it with another lesson. We might have a quiz on just this, or we may have a quiz on this and two-way tables, but you will be quizzed on this. And just to give you a heads up, your quiz will be a problem that is similar to one of these on the back page. I need to verify that you guys really understand this idea of a pie chart having to make up a whole, and whether categories make up a whole or the category is its own whole. If you have any questions, please send them to me, video, email, call, whatever works best for you. You want to get these cleared up before you take the quiz on this. And I think that's it. I'll see you guys in the next one.